Welcome to AfriLink Network Consult. In this part, we are going to explore the features of networks. But before we do that, let's refresh ourselves on the previous topic. So with the subnet mask, we learned that this /24 here is the subnet mask. So supposing we have a network, this is the network. It's a simple design of networks. So we have our router here and a cable connecting to a router to a switch. So on the switch, you can connect your devices, be it a printer, PCs, or IP phones. If you are to assign IP addresses to these devices, these addresses are going to be derived from this network ID 192.168.20.0/24. The /24 is telling us that the first 24 bit is a constant. It will never change for each IP address that you assign to a device in this network. It's going to be a constant. First 24 bit constant subnet mask. So the IP for this PC will be 192.168.20. Then whatever figure you have here will change. It can be anything. It can be .1, .2, .3, .4, and so on. But the first 24 bit is a constant. That is what the subnet mask is telling us. So if somebody assigns an IP of 192.168.8 here, .40, let's know it's wrong. This is wrong. 40 is not in conformity with this network ID here. So another example is we have a similar network. By this time, the subnet ID is 172.16.0 and .0/16. This is the subnet mask, and it's telling us that the first 16 bit is constant. It doesn't change. So if you are to assign IP addresses to devices here, 172.16, this is a constant. Any value here can change. It can be 7.1. as long as we have the first 16 bits to be constant. So another device will follow 172.16. Then anything in this octet and this octet can change. It can be 0.1 and so on and so forth. So that is a refresher. Now let's come to features of networks. Now that we have seen what a network is, we have seen a basic design of a network. So to hit on a point again, if you have a router, you connect it to a switch, you have a network. On this network, you can connect your devices. So this is a simple form of a network. Networks have certain unique features that we are coming to learn in this section. We are coming to discuss 6 features of networks. In this video, we only talk about 4, and the rest will be talked about in other videos. After discussing all these features of networks, we should be able to solve any question in IP addressing. Number 1, every network has a network identifier. So every network has let me write a full sentence. Every network has a network ID or network identifier. Every network should have a network ID, just as every family should have a family name, the Ofori family, and so on and so forth. How do we deduce the network ID? By turning all host bits to zero, sorry. So turn all host bits to 0. Then you can deduce your network ID. So every network has a network ID, and to deduce or to calculate the network ID, you turn all host bits to zeros. Let's see a scenario. So supposing on this our network, there is a PC or a printer in the network, and the IP address of this printer is 192.168/28. This is an IP address of a device within this network. As our rule goes, this network should have a network ID. And we are to deduce the network ID by applying rule number 1. Okay, so let's see how we can do that. 192.168, I'm just repeating the IP address of the computer in the network, /28. This /28 here is the subnet mask, and it's telling us that the first 28 bits is the network bit, implying 4 bits belong to the host. How do we get the 28 bits? Remember, in each octet we have 8 bits. So this 192 is 8 bits, 168 8 bits, 16 bits in all, 71 8 bits, 24 and 68 8 bits. If we are to count the first 28 bits, it will fall somewhere in this 4th octet. So it will be in our interest to convert the 4th octet to bits or binary. In that way we can count our 28th bit. After doing that, then we can apply our rule. So let's quickly convert the 4th octet into binaries. So repeating the whole address, we have 168.71. This time we are going to convert the 68 to binary, because the 28th bit will be in the 4th octet. Supposing we had a /22, which will be in the 3rd octet, then I will start my conversion from the 3rd octet. 68 is 64 plus 4. All other bits become 0. So we have 0 1 1 2 3 1 0 0. Yeah. So now we can count our 28 bits that belong to the network. So the first octet is 8 bits, 192. Second octet 8 16. Third octet 8 bits, 24, 25, 26, 27 and 28. Everything here belongs to the network or the n bits. Then from here up to here is our h bits or host bits. H bits is equal to 4, and the network bit is equal to 28/28. Applying our rule number 1, it says every network has a network ID, and to get the network ID, turn all host bits to 0. So these 4 bits that we are seeing here are all going to be turned to zeros. These 4 bits here, they should be turned to zeros. So 192.168.71. Remember, this 0, 1, 0, 0 are not part of the host bit. They are part of the network bit and they must remain constant, untouchable. But the last 4 bits here are going to be converted to 0. So 1, 2, 3, 4. We have applied our rule. So after applying the rule, we have to convert everything in that octet back to decimal. So we have 192.168.71 and .64/28. This is our network ID for this network. So our network ID for this network where the PC is residing, net ID is 192.168.71.64/28. Please remember that this network ID can't be assigned to any device inside this network. So if you have a PC here, you can't assign an IP address of 192.168.71.64/28. It cannot be assigned because that is a network identifier. So we have applied our rule. For every network, there is a network ID, and that ID cannot be assigned to any device. And how to deduce that ID? You have to turn all the host bits to zeros. Rule number 1. Let's go to rule number 2, or the second feature of networks. In rule number 2, it says every network has a broadcast ID or broadcast address. This address can also not be assigned to any device. And how do we deduce the broadcast ID? We do that by turning all host bits to 1s. So rule number 2, every network has a broadcast ID. And to get a broadcast ID, turn all host bits to 1s. It's a rule, constant. There is no network without a broadcast ID. Neither there is any network without a network ID. So let's use the same scenario here to deduce the broadcast ID for this network. So in this scenario, we have a network. We do not know what the broadcast ID is, but we know that a device in that network has this IP address. With this information, we should be able to deduce the broadcast ID. So let's see how we can do that. We are following the same step as we did in the first question, but this time we are going to turn all the host bits to 1s. So 192.168.71.68/28. Because the 28 bit is in the 4th octet, we are going to convert 68 to bits so that we can count our 28 bit 71. So 68 into binary, 64 is on, 4 is on. All other thing goes off. So we have 0, 1, 3 zeros, 1 and 2 zeros /28. So we can count our 28 bits. 8 bits here in this octet. Every octet has 8 binary numerals. So 8, 16, another 8 in the 3rd octet, so 24, 25, 26, 27, and 28. Everything here is our network bit, and it's equal to 28. Meaning we have only 4 bits for the host. So let's apply our rule for the broadcast. That says we should turn all the host bits to ones. So these 4 bits here are going to be converted to ones. In applying our rule, we have 192.168.71. Remember, 0, 1, 0, and 0 are not part of the host bits, so the rule doesn't apply, even though they are all in the same octet. So we leave them as they are, 0, 1, 0, 0. Then the last 4 bits here are going to be converted to ones, 1, 2, 3, 4. We have applied our rule, the broadcast rule. After applying the rule, we have to convert everything in that octet back to decimal. So we have 192.168.71 dot converting 1, 2, 3, 4, 64 plus 15, 79. So converting everything in the 4th octet to decimal, we have 79/28. This is our broadcast ID for this network. So for this network, our broadcast ID is 192.168.71 and .79/28. Yes. So we have seen the 2 features of networks. Every network has a network ID. And to get a network ID, you turn all the host bits to zeros. And also the network IDs cannot be assigned to any device within this network. Also, rule number 2 says every network has a broadcast ID. And to get a broadcast ID, you convert all the host bits to ones. And again, the broadcast ID cannot be assigned to any device. So you can't have a device here with an IP address 192.168.71.79/28. It's not possible. So rule number 3, or the 3rd feature for network, says every network has valid range of IP addresses. We can also call them unicast addresses. Every network has valid range of IP addresses. These are the addresses that can be assigned to devices. So the first valid IP address will start from 192.168.71.65. That will be the first valid IP address. So if you want to assign an address to a device, a PC in this network, you can start from .65. The next 192.168.71.66. It goes on and on. .67, .68, .69 till you get to 192.168.71.78. These are the valid IP addresses that you can assign to devices within this network. As I said earlier, they are also called unicast addresses. So, rule 3, every network has valid range of IP addresses or valid range of unicast addresses. Unicast. So how do we deduce rule number 3? How do we get a valid range of IP addresses? 3. So every network has valid range of IP or unicast addresses. And to get that, first of all, get the network ID plus 1. So if you add 1 to the network ID, that is 64 plus 1, you are going to have the first usable IP address, and the last usable IP address will be the broadcast ID minus 1. So the range, the first valid IP address is network ID plus 1, that is 65, to 78, that is the broadcast ID minus 1. That is the valid range of addresses from the 65 to 78. So to calculate the valid range of address, get the network ID plus 1 to broadcast ID minus 1. So whenever you are asked to calculate the valid range of a network, you first of all have to get the network ID, add 1 to it, get the broadcast ID, subtract 1, and you have your valid range of IP addresses. So rule number 3 is captured. What about the fourth feature? For every network, we have valid number of IP addresses. It's different from the range. Valid number. Number is the ones that we can count. If you are asked to count the number of IP addresses, valid IP addresses within this network, the IP addresses that can be assigned, you count 65 is the first one. 1, 2, 3, 4. We can't keep on counting, so there is a formula. Rule 4. Every network has valid number of IP addresses or IPs. And there's a formula. The formula says 2 raised to the power h minus 2, where h is equal to the host bit. The host bits. So 2 raised to the power h minus 2. Minus 2 because in every network there are 2 addresses that cannot be assigned. The broadcast 1, and the network 2. So if you want the valid number of IP address, you subtract 2 to get a valid. So in this our case, because it's a /28 network, our host bit here is 4. Every network is network bit plus host bit is equal to 32. So once we have a /28, it means the network bit is 28 plus h will give us 32. In this case, our host bit is 4. Fixing 4 in place of a, we have 2 raised to the power 4 minus 2. 2 raised to the power 4 is 16 minus 2, which is 14. So in this network, we can count 14 valid IP addresses. 14. So whenever you are building a network of this size, then you use a /28. An IP of 192.168.71.80 or 81 is outside the range of this network. So if you fix a PC here and you want to assign an IP address to it, and you choose 192.168.71.81 or 71.91, you are wrong. You have chosen addresses which are outside the range of this network. The range starts from 65 to 78. So now we've learned 4 rules of networks, or 4 features of networks. Let's solve more examples to consolidate our understanding. So we're going to create a scenario here. We are going to design a network and fix a computer in that network, give that computer an IP address. Then we'll challenge ourselves to find the network ID, broadcast ID, valid IP range and valid number of IP addresses. So let's do it. Let's design our network router to a switch and a PC or a printer in that network. And then this PC has an IP address of 172.167.114/22. This is the IP address of a PC inside this network. And we've been asked to 1. Deduce 1. The network ID for this network. 2. Deduce the broadcast ID for this network. And 3. Get the valid IP range for this network. And 4. Get the valid number of IP addresses for this network. So let's do it. Repeating the IP address, we have 172.16.114/22. What does this mean, /22? That is a subnet mask, and it means the first 22 bits belong to the network. In this case, what will be the host bit? 10. So let's put it somewhere. We need it. Let's put it somewhere. For now, we are going to use the /22 or the network bit. This /22 is somewhere in the 3rd octet. We cannot identify the 22nd bit unless we convert the 67 here into binary before we can identify the 22nd bit. So in this case, we are converting the 3rd and the 4th octet to binary. So 172.16.67 into binary is 64 plus 3, 2, and 1. So all other thing becomes 0. So converting 67, we have 0, 1, 4 zeros, 1, 1. Dot 114. Converting 114 to binary, 64 plus 32 will give us 96. So 96, we are left with 18 to reach 114. 18 is 16 plus 2. So the rest come 0. 114 is 0, 1, 2, 3, 0, 0, 1, and 0, /22. Now, we can comfortably count our 22nd bit. So the network bit, first octet is 8 bits, second 8, making 16 in all, 17, 18, 19, 20, 21, 22. So from here up to here is our network bit, and it's 22. These 2 bits and the whole of the 8 bits in the 4th octet belong to the host bit, which is 10. Now let's apply our rule. To get the network ID for this network, the rule says let's convert all the host bits to zeros. So we have 172.16. Remember all these 6 bits here even though they are sharing the third octet with some part of the host bit, this first 6 bits belong to the network, so they stay constant. 0, 1, and 4 zeros. 1, 2, 3, 4. But these 2 bits here, which belong to the host, will be converted to zeros. This. We are applying our network ID rule by converting every host bit to 0. So all the 4th octet will be zeros. 1, 2, 3, 4, 5, 6, 7, 8. We have applied our rule. That's all. So the next thing is to convert everything back to decimal, octet by octet. The most important is to be able to split the IP address into 2 parts. That is the network part and the host part. So converting everything back to decimal, we have 64 here and 0 in the 4th octet. So our network ID for this network is 172.16.64 and .0/22. What about the broadcast ID? The broadcast rule says that we should convert all the host bits to ones. So going by the same procedure, we're going to use the same address, converting the 3rd octet and the 4th octet to binary and choosing where the 22nd bit is. Now we know that every bit here belongs to the network, untouchable. The bits here are all going to be converted to ones. That is applying the broadcast rule. So we have 172.16.0, 1, and 4 zeros. 1, 2, 3, 4. We have applied our rule. So the 2 bits here are part of the host bit, and we are going to convert them to 1. So 1, 1. Fortunately, they are already ones. And everything in the 4th octet becomes 1. 1, 2, 3, 4, 5, 6, 7, 8. We have applied our rule. The next step is to convert everything back to decimal. So we have 172.16.67 and .255. That is our broadcast ID. So for this network, our broadcast ID is 172.16.67.255. So simple. So we can use any of these addresses. We can assign these addresses to devices within this network. If that's the case, which addresses can be assigned? So the valid IP range or the unicast addresses will start from the network ID plus 1. This is the network ID. We add 1 to it. So we have the first valid IP addresses, 64.1. To the last one, that's the broadcast ID minus 1. This broadcast ID. So the last valid IP address is 67.254. That is our range, our valid range. A lot of IP addresses. So if you want to assign, if you want to have a clear picture of the IP addresses, the next valid IP is 64.2. You move to 64.3, 64.4 till you get to 64.255. Because 255 is the maximum number you can have in each octet. You move to 65.0. Then start counting 65.1, 65.2, 65.3 till you get to 65.255. Then you move to 66.0, 66.1. You keep on counting till you get to 66.255. Then 67.0. and down to 67.254. A lot of IP addresses. So this is the valid range of IPs that we can have. So the size of this network is really huge. You can have a lot of IP addresses because of this /22. So let's solve the fourth one. Find the valid number of IP addresses. Valid number. Are we able to count all these IP addresses within the range, starting from 64.1 to 67.254? It's a lot. We won't be able to count, so we go by the formula. Valid number of IP addresses says that to calculate the valid number of IP address, use this formula: 2 raised to the power h minus 2, where h is 10. We know that because it's a /22. /22 is telling us that this IP address has 22 bits in the network portion, leaving 10 bits for the host portion. So fixing 10 up here, we have 2 raised to the power 10 minus 2. 2 raised to the power 10 is 1024 minus 2, and we have 1022 valid IP addresses for this network. So we have 1022 computers to fix inside a single network. Then you have to use a subnet mask of /22. The rule is applied. Thank you for joining us in this session. Always look up to more videos from AfriLink Network Consult. We are the best training center when it comes to Cisco network engineering. Our number is 0244 30 34 60 and also 0548 000052. Thank you.